Okay, so I guess we'll start. Today is the 25th of July. We're going to talk about data types and classes in R a little bit, and then we're going to do an application exercise on data types. And then lab 4, because we've got 2 application exercises this week, I'm asking you guys to try and do lab 4 on your own. But if we have time tonight and you want to, we can start on lab 4, or we can just leave it up to interested reader. All right, let's dig in. Let me share my screen. Okay, we are going to go to number 4, importing and recoding data. And a little bit of a trick here. The importing and recoding is the second part of this week. The first part is about data types. So it's really more about, well, it's kind of an aside. So anyway, here we go. Let's dive right in. Let me know if that's the problem to see it. Let me just size it right. Okay, so let's talk about data types. Why should you care about data types? Okay, so when we go into this, before we sort of go in and actually describe data types, which some of you might know something about, I'm going to try and go through a motivational example. So what we have is a small data set called cat lovers, and it was a survey to ask people their name and the number of cats they had, and I think whether or not they were left-handed for some reason. And so the first thing we do is we're going to read in from a file called data/cat-lovers.csv. So there's a data folder in the directory that you're in, and it's got a cat lovers CSV file in it, and read_CSV, like we learned last time, will read that data, do its best to guess the contents, and then put it into a data frame called cat_lovers. And if we look at cat lovers, we can see it's a data frame or a tibble, 60 observations or rows, and 3 columns. And the columns are the name, so that's the person's name, the number of cats they report, the handedness of themselves. And each of these column variables is a character array, which is typical for when you read stuff in. All right. So now the first thing I want to do is I want to understand what's the average number of cats that these respondents have. Okay, so I'm going to do what we've done before lots of times. I'm going to pipe cat lovers into the summarize dplyr function, and I'm going to say mean cats equals the mean number of cats. And if everything was perfect, it would come back and say, this is the mean number of cats that you've got, but it fails instead. And it says there are some, this argument is not numeric or logical, it's returning an NA. So something is breaking this. So we need to look at the data and see what's going on. So let's dig in a little bit. And so one thing we could do is look at the mean function and look at some of the arguments it takes. And if you just had a lot of time and you read the function, you'd notice that there was an argument called na.rm, which says whether or not to remove values, NA values, before you do the actual math. Okay, so you might assume there's NA values potentially in that variable. If it's very large, you can look for them algorithmically, or you can just sort of page through the data. In this case, we're just going to say, well, yeah, sure. I have a question.
So
Oops, can you unmute?
My question is, if you import a CSV,
yeah,
does it automatically put in NAs if you have blank?
It will, yeah. We'll talk a lot about importing in a little bit, but that's in the importing section. It's a good question. Yes, it will, though. So if there's a cell that's empty, like an empty cell in CSV file is like comma and then nothing and another comma, that's an empty cell, and that, yeah, that'll turn into an NA. So I just guessed that maybe there's NAs in that column, so I said NA equals RM equal true, and it still barfs on me. It can't figure out how to calculate the mean. So really what I need to do is I need to look at my data. So
You say true. I thought it said false.
I'm sorry. NARM equals true means remove NAs before you do the calculation. So you seeing what I'm seeing?
Yeah, does it remove the whole row?
It will remove any observations. Yeah, so it reduces the number also. No, it won't make it a 0. It just it makes the data set smaller that you're operating on. Yeah. Okay. So let's take a look at the number of cats variables. So if I just look at it, and remember I'm trying to do a numerical mean on it, you can see that each of these columns are character strings. Okay, Bernice Warren, that makes sense that that's a character string, but these numbers here are also, anything in a quotes, FYI, is a character string, and it's generally not an integer. So this is a problem. If these guys are, when you read a CSV, a lot of the time this happens, that even if they're integers or doubles, when they get read in, they're converted to characters, kind of dumbly, unless you are a little bit more explicit about how you read them in. So I could say, oh gosh, wow, I can't take the mean of a character string. Let's go fix that. But before we do that, we're going to just look at the data. So we can look at, so this is just a data table format of all of my data. So I got my name column, my number of cats column, and my handedness column. And I'm just going to page through and just look and see what's going on with my data. So far, number of cats looks pretty good. A lot of zeros. Oh, but then here, number of cats here says 1.5. Honestly, I think one of my cats is half human. So Ginger Clark decided she wasn't going to put a number in here. She was going to put a number and a comment. So that's bad because there's no way I can algorithmically figure out how to turn that into a number. And Doug Bass decided he was going to write out 3 instead of typing in the number 3. So there's 2 things here that are character strings that can't be easily converted into integers that we've got to somehow deal with. So if we find those data in our data set, we can mutate them out, right? So we're going to use the case when statement, which is maybe new. It's kind of like a switch statement in other languages, or it's kind of like an if else, a lot of if else's, but they're all in one place. And so let's just go through this. So if I mutate and I'm going to say number of cats is the variable that I want to make, it equals, I'm going to do the case when, and then if the name variable is equal to, so equals is a test. If name equals Ginger Clark, squiggly means then replace the value with whatever's on the right side. In this case, it's a 2. And then I can string lots of these cases together. So if my name is Doug Bass, then I'm going to replace it with a 3. Remember that Ginger Clark's answer was 1.5. I think my cat is half human. So we're assuming that's really 2. And then Doug Bass wrote THREE, and we're going to replace that with a 3. And then true means for every other case, it's like a default. Otherwise, I'm just going to convert number of cats to a numeric. And then I'm going to summarize that data set to do the mean number of cats. And now what I get is I still get a warning, so we're going to have to talk about this, but then I actually do get a numerical answer. 0.833 cats is the mean number of cats. But let's look a little bit about why we're getting this warning. And the reason's a little bit cryptic, but I'm going to keep going.
So I had kind of a question, but
yeah,
I mean, it's obvious the answer. You can mutate to an existing column name.
So yeah, so it looks that way, but it's not. So the way the way all dplyr functions work is they don't ever modify in place. And so what's happening is it's going to read in the data frame. It's going to write out the data frame, except for it's going to make a number of cats. It's going to make a new number of cats column. And so it looks like it's changing in place, but really it's just writing a new one out. So it's not modifying cat lovers, but yeah, you can overwrite. If you overwrite the column, you'll change it to whatever. Yeah. You can also, like, if you just wanted to rename, there's a rename function, but this is if you want to actually change the contents of the data. But yes, the answer, long way to say yes. So the reason this is happening is that this we have to be a little bit careful when we do these replacements, because I'm doing this as numeric on all of the data except for these 2 rows, and these 2 rows, because the number of cats on the way in was a character string, these actually come back as character strings. So this is just a little weird way to do it. If I do my replacement and then I coerce the entire thing afterwards to a numeric, then I can get rid of that error, because I need to sort of respect the type on the way in. So what I've got is kind of 2 mutate statements here. One of them is number of cats and my case when, and I'm replacing the data that says 1.5, I think my cat's half human, and the one that says CHRE with characters 2 and characters 3, because it's still a character string, and then all the other characters. And at the end of that statement, now I've got a well-formed vector of character strings that can easily be turned into numerics. And then I do all of them at once. I do this coercion into a numeric, and that's a good way to do it. Another way would be just, pipe it into another mutate or something like that if you want to really separate them. But anyway, this is a nice clean way to be able to do the mean number of cats without any warnings. And the message here really is just the data types are important when you start operating on them. You need to understand what they are and if you've got exceptions, and you need to handle all the exceptions, or else you're not, if you get a warning, you can ignore it a lot of the time, and a lot of the time it'll be right, but sometimes it's going to do something kooky, and if you don't sort of dig in, you're not going to know if you've got an error or not. So warnings are actually very important. R will do a lot of stuff, give you a warning, and maybe not do what you really thought it was going to do. So if you get a warning, you really got to make sure that you can ignore it or not.
How do you see the data type again? You have to do a view, or can you do?
Well, yeah, you can do a glimpse, or in fact, if you just type it out, either way, the data type of the vectors will come out. So you see,
if you do name.
well, if you just type it, like just say cat lovers, it'll tell you here the type of the vector. If you do names, it won't. No. All right, so okay, let's talk about the moral of the stories. I think that's where we're at now. Yeah. So if your data doesn't behave how you expect it to, type coercion upon reading the data might be the reason. A lot of times when things are implicitly coerced, when the types are sort of assumed, that you can get into trouble. All right. So now if you fix your data and then save it to a different data frame, then you can keep going, basically. All right, so now that was motivation. Now we're really actually going to dig into like all the data types in R. So I want to differentiate data types. So we're talking about like strict like data types in the language R versus like types of variables that we talked about last week, which was like, you've got categorical variables and numerical variables and continuous and discrete. These are subcategories kind of those variable types, but these are data types in the language of R. All right, so these are there's really just, there's a bunch, but these are the main ones: logical, double, integer, and character. And we'll talk about the aspects of all of them. It's in the other languages, there's a lot of other kind of like doubles and floats and how long is your integer, but generally in R they don't do that. They kind of go for the big end always. Okay, let's talk about logicals. So obviously, like, maybe it's not obvious. A logical is a true or a false value. And another way to say it is a Boolean value, and there's a Boolean arithmetic is a thing that we'll talk, and I think we talked about last week a little bit, which is the ors and the ands to combine logical values. But anyway, if you have a logical value is a true or a false, so if I do the type of true, which is a logical, it'll tell me it's a logical. And if I say like x equals true, and then I say type of x, it'll say it's a logical. Character strings are these quoted things. Anything in quotes is a character string. And the type of that is character. So it's a character vector, so it's actually a sequence of characters. So they don't really differentiate between character and string in R, which is a little bit weird. It's like in other languages, a character is a different thing than a string, but here it's all the same thing. I don't think you can actually have a character in R. These are all strings. So, and then there's integers and double. So double is a floating point value, and a double traditionally is like a float is a single width, and a double is double width floating point value, but it's just doubles here, and that just means that you have a decimal point and numbers after the decimal point, basically. And the way to specify some of these is a little bit different. So the type of a number 1.355, obviously that's going to be a double, but if you say type of 7 and there's no dot, it still interprets it as a double. So if you want to be explicit about making it an integer, sometimes you care to do this. You have a trailing L. So 7L is an integer. And also ranges are interpreted as integers. So 1:3 is really a vector of integers 1, 2, and 3. So that's just the way it is. You don't have to remember it. You can always refer back, but it might be important sometimes. Okay, so now you have seen the C function before, and the C stands for concatenation, which is just a fancy word for putting stuff next to each other. And you can create vectors of any of these types by just putting them inside of a C and comma delimiting them. So C1, 2, 3 is the vector 1, 2, 3. And then C of hello and world, which are both character strings, is the concatenation of hello and world. And you can, if you nest concatenations, the result is always a flat vector. So I have two vectors, C hi and hello, and C bye and jello. And if I concatenate those together, I have a single 4-element vector, hi, hello, bye, jello. Is that clear? Okay, now we want to talk about converting. So if I go x is 1 to 3 in that range, the type of x is an integer. We just talked about that. It's a range, so it's an integer. And I can also convert, if I convert x into characters, into a vector of character strings, I would use the as character function. And that would take the 1, 2, 3 integers and convert them to a vector of character strings, character string 1, character string 2, and character string 3. And same thing here now. Let's talk about logicals. So I can make concatenate logicals together into a logical vector. So C of true and false goes into X, and X is a vector now of true and false. And it's a logical value. And I can convert that, I can coerce that, cast it into a numeric using as.numeric. And that turns false turns into 0 and 1 turns into a true. And then if I take the type of that guy, it's a double. So it's a vector of the doubles 1 and 0. And now if you start mixing types in a vector, which happens, there's some rules for conversion, and there's sort of this sort of type hierarchy where characters down at the bottom, and there's a bunch of stuff up higher up, and you always go to the lower common denominator. So if I'm concatenating 1, which is a double, with hello, the string, I can convert 1 into a character string. I can convert a double into a character string, but I can't really convert a character string into a double unambiguously. And so what happens is I convert them both into the vector with the same type of character. And then same with a logical and an integer. I can convert a logical into an integer, but I can't convert all integers into a logical. So the false would be turned into a 0, an integer 0. I can also do it explicitly, but okay, here's some other examples. So here's another one with doubles and integers, right? I can convert a double into an integer, but I can't convert, wait, I'm sorry. I can convert an integer into a double just by saying it's point, instead of L, it's a dot, it's 3.0, but I can't convert 1.2 into an integer without changing its value, without rounding or truncating. And then integers and character strings. Okay, that's the same as the first one, except it's an integer. I can convert almost anything into a character string, but I can't convert a character string into an integer, and so they get converted down converted into characters. So we got to be careful when we operate on this kind of stuff. All right, so those were all sort of implicit coercions, but explicit conversion is when you use these as functions, as logical, as numeric, as integer, as double, or as character. And then implicit coercion just happens if you sort of throw things together, like you make a vector with different types, it's going to convert it to the lower type.
That's probably what happened with the cats, because there were
Yep.
two in there.
It had to convert them all to a character string because they have all of those elements in the vector have to be the same type. Yep.
So
Okay.
what's the difference between as numeric and like as double or as integer?
That's a really good question.
Okay, you don't have to answer it.
I don't know the answer. No, you stumped me on that because double and integer are obvious, and numeric, I think I don't know the answer. I'll find out. It's a really good question. You got me.
Yeah, maybe integer and double only converts a number. I don't know. An existing number.
No. Well, so we went back to these examples.
That's converting text, right?
No, it's converting logicals into numerics, and the numeric is a double. So I think numeric and double are the same, to be honest with you. And numeric actually might be a float. I don't know. It's a good question.
Okay.
Anyway, we'll take that one offline. So we're going to do an application. We're going to start the application exercise now. So I am going to go over here and start a new. I'm going to go back to YaRDS. I'll put this in the chat. We're going to go to number 4. We're going to go to this application exercise. I'm going to copy this guy and stick it in the chat. And you want to start up in our studio with this guy here. Oops. Get that? Yeah. So I'm going to start up a new project. And do the normal stuff, knit it and stuff, and then we'll walk through. And this is about coercion. It's going to ask you to guess the types of implicitly converted coerced thingamajiggies. So let's see, what type coercion. So you want to open this one, yeah. So I'm going to go over to our studio. Do you guys have this loaded or? Okay, let me know when everyone's got it loaded.
So you don't want the hotels?
No, that's later. The coercion, yeah, 4 cats is later. What are some of these names? So I'm going to knit this. I'm going to preview it in my viewer pane. I'm going to click on knit. It doesn't include tidyverse, and so you don't have to do a ton of early loading of installing stuff. But you do have to do this one. So let me know when everyone's knitted. It's still loading stuff. No way you've knit. Have you knitted? Really? Mine took a long
Please
time.
download tidyverse again.
No, it won't. You don't need to. No. It's not using tidyverse in this one. When you knit, it'll ask you to say yes to something. I forget what it's loading now. String R or something. Raise your hand when you're when you've knitted successfully, and then we'll start. So this one's a little, it's interesting. It's a little bit complicated.
Yeah, what the hell is that?
Yeah. We'll start.
What were we supposed to guess?
Well, let's do it together.
So what the last slide said was
Well, Shamila's got it. Pete, are you loaded? Is yours loaded? Raise your hand. Okay.
No, I loaded it, but I have a different. Where did you get this again?
I put it in the chat. It's an
Oh.
application exercise.
Yeah, I loaded it from different Git repository, and it's different. So
There's a bunch of hotels ones. It could be, there's another application
yes,
exercise
okay.
on Wednesday. So this one is just about data types, data type coercion. And so well, let me just walk through what you're seeing here. So the first, so if you look on line 10, are you still loading, Pete? Do you want me to wait?
No, you can go ahead. I'll just load it.
Okay. So what we want to do is we want to guess what type the vector is going to end up being. So I've got C, which is, we talked about concatenation. So C is making a vector out of one L, and then the string C. So for some reason they didn't put type of, but I think we want to put type of each of these to see what the types are. So first of all, does everybody know what these types are? You want to guess what these types are in 14, 15, and 16? On line 14, 15, and 16? Oh, yeah, no, look at the source. Is it too small to see? I can make it smaller or bigger.
So 14, 15, and 16.
Yep. So let's just guess what these are. So tell.
Like a.
Is it double?
Yep.
But why is that even R? Like, why is that an R block? I don't understand.
It's just the number one, and it's an expression. One is a mathematical expression that is one. So
Why is it in a block, I guess?
Because can you see what I've done? So if you
Hold on, I just got we're in hotels data types.
yeah. Okay, so Shamil guesses double.
This doesn't even have a C. Like, what is actually happening 13 through 17?
So all it's doing.
What's the function?
There's no function. So if you go, so let's do this. Okay, I'm going to just take a tiny aside. Go to your console. Okay.
Yeah.
Type the number 1 and return. And what the interpreter is doing is saying, oh, that's the number 1.
Okay.
And that's it. And so it just returns what it's given. And that's what it's going to do in that R block. But if you type of 1 in the console, and we're going to do it on lines 14, 15, and 16 also, you'll see that that the type of that number 1 is a double. Does that make sense?
I guess so. I mean, do you have to type 1 first? Can you just, like, why have the first block? Like, couldn't you just, like, what?
Let's just, don't worry about the logic of what we're doing.
Okay.
We're trying to understand these data types. This is just a very simple, not useful example of just trying to like figure out data types. So 1L is an integer, right? I'm just guessing it's an integer because that's what we just learned. And then we know the character C, the string C is of character type. You don't have to do this, but the key part is what we want to guess on line 20. This has been commented out. If I coerce together, if I concatenate together a double, an integer, and a character, we based on the rules that we just talked about in the lecture, what type of string? Yes, so you're guessing that this will be a character vector, right? So let's just do that change and then just uncomment out line 20 and reknit, and it will tell you the answer. I didn't spell that well. Okay, so it's a little tough to see, but if you see, yeah, it's of type character, so that's correct. So we're basically going to go down and do a few of these things. We haven't talked about.
Actually,
That's where we haven't talked about
it
not a
only
number
says
set.
one.
What is the type of the given factors? First guess, try running on guesses. Okay, so we're going to do this. Pardon me. What? Line 20 or line? What line did you do?
What's on 24?
I have nothing. I have a blank.
Well, I have the C.
Oh, that's just echo. It's not code. It's just a label. And then on 26 is the actual character vector in R. So try and decode this. I'm sorry, not the concatenation of these two things. So I'm concatenating. So do you want to go on to 26 or
Sure, is that a slash mean divided by?
Yep. So so do you want to interpret what this first expression is? So there's two things I'm concatenating. The
Yeah,
first
so
thing,
there's 1 divided by 0, which
Right.
is infinity.
that's right. Yep.
So that's a mess.
And then the character A.
Yeah.
Yep. So if we look at on the right, so lines 30 through 33 has already been done for you. So the type of 1L, the type of 0, and then 1L over 0 and A. If we go to the right side, we can see that those types are 1L is an integer, 0 is a double. 1L over 0 is a double. That's the type of it. And then A is a character. So again, we've got an integer, two doubles, and a character, and we're making, I'm sorry, at the end of the day, we have a double and a character that we're making into a vector. So what type will that end up being? Yep. So you can get rid of that on 37, and let's just reknit and validate that that's really true. And you've got to scroll down and kind of look and look and look, and yeah, this type of here is indeed a character. All right, I'm going to add a little bit of heading so that we know where we are here. So I'm going to concat range and double.
We put that under.
On 39, I just did that so that you, yeah.
Yeah, because I put in comments too.
Oh, okay.
So after.
Right before the C1:3. So 1:3. So we are on the right side. It's already given to us that 1:3 is 1, 2, 3, and we know that the type from the lecture, and it's shown here on a little bit farther down, the type of the range of 1 through 3 is an integer. And the type of 5 is a double, like we learned, right? So now we've got a concatenation of integers, a range of integers, and a double. So what is that going to end up being? Yes, I think that will become a double. So let me do this. Is this a double? And now reknit. So I'm on 52. I just updated 52 or thereabouts. Where are my headers? Okay, concat range and double. And then is this a double? Type of double is a double. Yes, that's correct. All right, let's keep going. Is everyone there? Am I going too fast or? Okay. You guys good? Now the next one's kind of interesting. It actually set me back a minute when I was looking at this. So I'm what is 3, 3 plus? So the type of what's the type of 3? Anybody? It's a double because 3L would be an integer. What's the type of 3 plus?
Character.
It's a character, right? So I was a little bit confused by that for a minute because I thought it might have been a math thing, but it's not. All right, so if you have a character, if you're concatenating a character and an integer, you get character, yep. So let's just reknit that one. And if you have a little heading like what is 3 and 3 plus, you can pull it out here so it's not impossible to find. And the type of 3 and 3 plus is indeed a character. All right, now we're going to move on to some logicals. Okay. Logical cats. So I'm going to look at the concatenation of NA and true. Yeah. Okay. So in the lecture, I don't know if we talked about this, but if you do a type of NA is the logical, and type of true is obviously logical. So I'm basically we'll actually talk about that in 5 minutes. But if we concatenate 2 logicals, we're going to get a logical. All right, let's reknit and make sure that that's actually right. And yes, the concatenation of 2 logicals is logical. So this is just a little exercise to sort of walk you through the paces of implicit coercion for vectors. That's kind of all
So
that
is it NA equivalent to a false or a 0 or?
That's a really good question. You're a good straight man. I think we're going right into it, or we're going to go
Okay.
into it after a minute. But let me just go through. We'll get to it really soon. Okay, so now this is okay. I think I should have done this before the actual application exercise because this is basically what we were trying to do, right? If you've got the type of 1, which is a double, and A, which is a character, and if I concatenate them together, it's gonna downcast it to a character. That was the example. Okay. All right, special values. Okay, here we go. So there's 4 special values. NA, which is like, I don't know, not a number, which is not, I don't know, it's different. And then there's plus and minus infinity. So how do we get these? So positive infinity is pretty easy. Any positive value divided by 0 is infinity. It's plus infinity. If you take 0 divided by 0, that's a special case, and that's not a number. But it's not nothing. It's just not a number. It's 0 on 0. And if I subtract infinity minus infinity, I also get not a number. But if I add infinity, it's still infinity. And I don't know why there's no negative here. Negative pi over 0 would be negative infinity. Okay, so NAs are special, and if you want, you can call them special snowflakes. So if I have, this is a simplification of that cat lovers vector. If I have a vector 1, 2, 3, 4, and then NA, and I do the mean, I get basically, oops, damn it, sorry, my mouse. I get this NA back because it doesn't know handle it by default for some reason does not know how to handle NAs, so I have to explicitly say NARM equals true, and then it gives me the mean of what's left over. So it's 1 plus 2 plus 3 plus 4 divided by 4. Now,
Silly question. Why doesn't it do that automatically?
I don't know.
Okay.
So mean is a base R function, and summary. Actually, I think summary is also a base R function. If you use summary, though, it does NARM equals true by default. Okay. And so if you did, so it's just the way it was implemented. Remove NAs. So if you do summary, it does remove them, and it tells you how many NAs there are, which is actually really nice. How many did I remove? There was 1 NA in that vector.
It literally removes it, doesn't put my 0.
That's correct. It removes it and it subtracts 1 from the number it's going to use as the divisor. Yeah. Okay, so let's talk about why NAs are logical. This is actually really interesting. so the type of NA is logical. And so I guess NAs could have been anything, and this is just sort of like a decision that they made, that the authors of the language made. But anyway, NAs are unknown. Obviously, we don't know anything about them. But R decided that they're going to make them into logicals, and so that now you can do Boolean operations with NAs. You can't add NAs, but you can do Booleans with them. So if we think about if I can do like true or NA, and if you do that in the console, you'll see that it comes out to be true, because true or anything logically is always true. So that one's easy. But false or NA,
True or anything.
yeah, so that's just that's just logic. So ors, I'm not sure how to describe that. In logical operations, like true or true is true, true or false is true. It's just kind of the way it's defined. And like if you use and operations, true and true is true, but true and false is false. It's just how logical operations are defined. We didn't talk about that, but it is. But so let's go. I can come back on that. If we think about NAs, if NAs are logical, if NA is logical, it could either be a true or a false. So true or true equals true, and true or false equals true. So true or NA equals true. So that's what we did, and that made sense. But now if you look at false, if NA is logical, it can take on either value. False or true is true, but false or false is false. And so the answer is NA, because it can take on true or false. So I think it's kind of an aside. You may not end up ever using that, but it's just sort of an illustration for if you do logical operations with NAs, you're going to get this kind of result. Okay. So with that in mind, actually, let's skip on to the next part. So that was data types. And now let's just dive right into data classes. And yeah, it's 7:45. I think let's just keep going. All right. Unless you want to take a break. You guys want to take a break? I think we should be able to get through this and maybe either end early or go into the lab. All right, so data classes. So if you've taken object-oriented programming, you know what a class is, but in this case, we're not going to actually go into the object-orientedness of classes, just that they're sort of types of structures of data. So mental model wise, so vectors are kind of like Lego building blocks, and we can stick them together to make more complicated structures. And the class attribute is another attribute of an object. So there's a type of an object and there's a class of an object. And the type is a low level construct, and class is a higher level construct that tells you more about what the data really is. So we'll get into some examples of that. But some very important ones are factors, dates, and data frames. So we're going to dive right into factors. So we talked about under variable types, we talked about categorical data. And we talked about categorical data either being ordinal or not ordinal. And if they're ordinal, they have an implicit order, and if they're not ordinal, they don't. So for example, this factor here is sort of ordinal, right? Because these are degree levels, right? And so there's BS, which is bachelor's, MS, which is master's, and PhD, which is PhD. And so they kind of go in that order. So they're an ordinal categorical variable. And I'm creating this factor. And the factor is has to be a known set of well-defined things. And so it's just assuming here that all of the things that it sees, that it's gonna take just the distinct elements of it and create those as levels of the factor. And so in this case, when it creates that factor, the first thing it has is the factor, the actual variables of the vector, which is BS, MS, PhD, MS, and then the levels of the factor, which are, they just happen to be, in this case, BS, MS, and PhD, but they weren't actually explicitly
What's the MS
told.
at the end?
So the factor is doing two things. One of them is it's encoding this vector, and this is an arbitrary length vector. It happens to be 4 long. It's a little confusing, but there's only 3 levels. There's BS, MS, and PhD are the levels, but
Okay.
yeah.
And it just happens to be in order in the beginning.
Yep.
Okay.
Yeah, and so, but you can order it if later on if you want to, because you'll end up doing that like with months and stuff. So if you so here's the type and class difference in terms of factors, right? The type of this X, which was made by a factor, is integer, but the class is a factor.
Integer.
Yeah, because it's a list of numbers that have that don't make sense with decimal points on them, because it's a range. They're basically, it's a range. Well, the way that factors are encoded are like sort of gluing 2 parts together. There's the actual factor names, or the levels, the BS, MS, and PhD, and then the representation of that vector is in integers 1, 2, 3, and 2, and the integer values are basically looking it up, and they're decoding those 3 levels. So 1 decodes to BS, 2 encodes to MS, and 3 decodes to PhD. That's just how they do it. There's 1,000 ways you could have done this, but that's how they did it. So now let's pop over to dates. We're going to do more of this. So dates are super important and also gnarly, and so that there are a lot of really good date support in R and in tidyverse. And if you take a sort of date-like thing like 2020-0101, and you say as dot date, you're coercing that string, that character string, into a date. And if you look at the type of it, it's of type double, and I don't even know why, actually. But the class of it is class date, and that's what's important. Yeah, it's a little arbitrary, and dates are actually represented as integers, so I'm not quite sure why it would be a double, because it's really just the number of days since the epoch, which is defined as the 1st of January 1970. And everybody uses that for January 1st, 1970. That was like the beginning of computer time.
That says time. Not really.
22. It's the number of days between 1 Jan 1970 and 1 2020. That's 18,262 days.
Yeah.
And then you can, if you can roughly sort of suss it out by, if you divide it by rough number of days in a year, 365, you get about 50 years, which is like the number of years between 1970 and 2020.
Wait, so I'm gonna, in the previous page.
Yeah.
It says type of Y is double.
Yeah, I don't know why. It doesn't make any sense to me, actually. If it was a time, it might make sense, but as a date, it doesn't. It should be an integer. I don't know why. It's goofy. There's some goofy stuff, and you really care about the fact that it's a class. You don't really care that the type's double. You care that the class is a date, because then you can do a ton of cool date stuff with it. So it just is what it is. I don't have a good answer for that.
Are there 2 likes?
Sorry. Oh. Oh, that's a typo. All right, so we talked about dates and we talked about factors. Now let's talk about data frames. So data frames are a special kind of list of vectors, and they're they're gluing a bunch of vectors of equal length together. That's why the type of the data frame is actually a list, because it really is a list of vectors, but the class is the data frame. And again, the class is the important part. So you know you've done it right if you get the class of it and it's a data frame and not a list. Yeah, you don't really care about it unless you're like digging deep to debug some goofy thing that happened. Lists, on the other hand, don't force you to have equal length vectors. So you can make a list of a length 4, a length 3, and a length 2 vector, which is like in this example. You've got an integer range 1, 2, 3, 4. You've got this concatenated characters, 3 character strings. And then you've got Z, which is a concatenated logical, which is just 2 elements. And if it's a list, it happily contains all this stuff. Turns out it's a lot harder to operate on it than if you have a data frame. If you have square data, it's much, much easier to operate on. That's why data frames are so commonly used. So probably ignore lists. You'll probably not use them much. But a data frame is a special kind of list, and the vectors all have to be equal length. You can pull a vector out of a data frame with the pull function. That's actually handy because if I select just one column, I'm still going to get a data frame back, even if it's just a data frame with a single variable in it. And I have to actually pull the, I have to pull a vector out of the data frame with one variable in it. If I don't use the pull, I've got to like use dollar notation or some other kind of notation. So that's a handy dandy thing if you want to get a vector out of a data frame, just one. All right, so that was long and confusing. But now we're going to dig into factors, and this might be confusing too, but we're going to go through it. And we're going to, you want to take a break now? Yeah, okay. Yeah, all right, sure. I guess let's take a break and come back at, when do you want to come back? 8 o'clock, 6-minute break? All right, let's take a short break, fast nature break and such, and we'll come back. We'll come back at 8. You guys good with that?
Sure.
Okay. All right, ringy dingy ding. Hey Pete, guess what? A double is exactly the same as a numeric. Bam! He's not back yet. I hear motion. Oh gosh. Oh, there he comes. Hey, Shamil. So Shamil's back, Jackie's back. Pete, are you back?
Yeah.
I would like to bring your attention to this, as double is the same as numeric. Bam. Okay.
Okay.
Let's work with factors because they're super fun. Okay. So we're back to the cat lovers again. So we've got Bernice, Woodrow, and Will, and their number of cats, and they all seem to be left-handed, which is odd. So this is a data frame with 60 observations in 3 columns, all of which are character strings in this incarnation of it. And if you go and you try and plot this, now if I ggplot cat lovers, where I'm going to make a geom bar. So geom bar, for those who remember, is a counting. It's going to group and count the number of observations in each of the groups of handedness.
Yeah, I didn't never do that.
That's what it does. There's a whole lot going on in geom-bar. And the thing with this though is that I might want to have this in a different order because I want the right to be on the left, for example. Ambidextrous is boring because there's so few, and so I want to put that over on the right because people start from the left when they read stuff in English.
So it's not counting.
It's counting the number of observations, not the number of cats. Yeah, you'd have to use GM call to count the number of cats. So let's talk about how we do that. So there's all these crazy functions in FCT. So you can
Maybe good.
need something like this.
One is
one's
veggie.
meat and the other one's not.
The little one is the veggie.
So
cauliflower bean.
I
and the
can
little one is chicken.
I can rewrite handedness in cat lovers using this factor in freak of handedness, and that will put the factors in order of frequency from high to low, and that allows me to get my right on the left because I know it's the largest one. And we'll talk more about this. This is just an example. So I can, if I mutate this, I can then I can change the order when I plot. So let's keep going. Oh, this is the 4 cats. This is the 4 cats package.
Mutate. And then let's keep it going.
FCT in freak. There's a bunch of them. They're
So-
freaky.
Just a quick question. Mutate, I thought, was changing your data frame,
It is, yeah.
but in this case, it's affecting a bar plot.
Yeah, isn't that crazy?
I didn't quite understand why.
I don't know how it does it actually, because I think it does have to do have some special metadata in there in order to make it work. Because you're right.
Okay, it's just confusing.
Yeah, it is a little bit.
What is it? I missed that.
We'll get to it, but it's one way that you can reorganize your data. So this is factor in frequency order. So you can rejigger your handedness variable to be in frequency order, and it's doing some special stuff so that downstream the geom bar can order it separately. It's kind of magic.
What's the range?
Oh, so it's like changing all the rows then, or something? It's figuring out the frequency and then moving them around? in
I
the
don't
date?
think it is. I don't think it's gonna. I don't think it's arranging the rows. Actually, I don't think it. I don't think it
Okay.
can do it that way. Really, I think it's inserting some metadata based on some of the counts. I don't know how it does it.
Okay.
It's just
Is that-
What's the difference between this and a range?
arranges your data. It rearranges, sorts your rows. But this GeoMBar is doing an aggregation. It's doing summary statistics to do these counting, and so
That's already done in the other one.
yeah.
It's just arranging it in its presentation, right?
Yep, it's just to change the presentation, but you can do it for other stuff. It's just an example right now, and I don't know how it works, so I can't tell you. I can look into it if you're
So
interested.
I just want to remember what the difference, like when would I use arrange, like why would,
Well, if you're doing a GeoMBar, if you're doing any counting and summary statistics, the order of the observations doesn't matter because they're being summarized. And so if you're doing, you wouldn't use arrange if you're doing.
would sort the rows.
Yeah, and so if you want to show your data in a certain
number of cats or
order,
something.
right? Yeah. Yep. So let's keep going though, because we're going to talk about 4cats, and 4cats does a ton of stuff with factors, and a lot of it is rearranging factors in certain orders and stuff.
What's it?
It's called 4cats, and it's another pun. So I told you before that computer scientists love puns. This is an what's the word? It's not an onomatopoeia. It's an anagram, right? 4cats, if you rearrange the letters, is factor. And I think part of the pun is that factors, a lot of the stuff that you do when you play with factors is rearranging the order of the factors. And, you know, it just is. So factors are useful and used when you have real categorical data. And a lot of it has to do with ordering of these character vectors to change the display of what you're displaying, right? So like we saw before, factors are these sort of ordered lists of character vectors, and then this integer, integer vector, arbitrarily long integer vector that encodes the factor values. They're also useful for modeling, like if you're going to do designs of experiment, factors are very, very useful. And anyway, this package gives you a lot of utilities basically to help you solve common problems. All right, and somebody likes cats. I think that's why they ended up with the 4cats, because these cats are in a box. There's nothing like cats in a box. All right, so now we're going to go back to the application exercise, and we're going to open this other markdown file, this 4cats markdown file. And what we're going to try and do is we're going to recreate this graph, and the challenge is to order the months in the graph properly from January to December, and then there's this stretch goal to number your axis. So this takes a little bit of Googling around. It's not just sort of handed you on a platter. And we can go the simple route or the complicated route on this one. I'm kind of thinking we should go the simple route, just to sort of show you how to do it, because it'll take a little while to actually go through it if we're kind of discovering on the way. So I'm going to actually jump to the solution, unless I don't have it here. Oh,
What's this there?
hold on. What is a search goal? Anybody know what a search goal is? Hotels 4cats. Hotels and data types. Oh, no, I'm sorry. This one. Okay. I'm sorry, I forgot I had it. So go back to the project that you had opened up in the previous session, and just open it up, and we're gonna go up and knit it, and then I'll talk you through what you got to do to make this work. It's a little bit complicated. Yeah, it times out. So if you go to 4cats, so we did type coercion. Now go to 4cats. I already have my 4cats open, and knit. And there are maybe other ways. So there's lots of ways to do stuff in R. There isn't just like one way to do most things. And let me just walk through kind of what I did. And I want to just sort of just walk through it quick. So knit the document and then describe to me how your rows are ordered, because they'll be different in mine. Okay. Oh, yeah. Because it's a different R Markdown file, and we didn't install tidyverse before. That's why. So let me know when you're there. I was looking around today, and actually I found a third way of doing this exercise that might actually be easier than the first two that I was playing with. But they're all roughly equivalent.
Isn't this file or like this workspace the other one we were just doing?
It's the same workspace, but the file is different. The file you want to open is for hotels for cats.rmd, not the type coercion.rmd.
Oh, okay, okay.
Okay, I got it.
Okay. So everyone raise your hand when you have knitted and all of your stuff is good, and and we can all proceed, because it's a little complicated, so I want to do it together. Yeah. I'm actually going to go, maybe I'll go back and maybe I'm going to do another RStudio, and I'll open the not filled out one also, just so I can refer back and see what the original looks like, and I've forgotten something. Okay, so Pete and Jackie have raised their hands. Still loading, Shil? And now I'm going to be the
Yeah, just loading them.
Okay, let me know when you. Well, while we're loading, we can walk through at least the first few lines. What's that?
View the following visualization. Gives you that.
Yeah. So it's pulling in these two packages, tidyverse and skimmer, and then it's reading the CSV file that is actually at this internet address under GitHub somewhere, and it reads it into the hotel's data frame. Yeah, and then all it's doing is this plot. So I've got hotels, and I'm piping it into.
Maybe get back to the.
It's at in the bottom. Oh, this popped up fast. All right. Can everybody knit and see their original file? Are you able to do that?
I did, but then I clicked on one of the links and now I'm down.
Oh, here, come here.
I also noted.
What's that?
I was able to knit.
Okay, good.
Yeah, I clicked on this link. See, for inspiration.
Yeah, don't click on any links. So what exactly? Right. So if you look at the arrival date month variable, which is these months. So okay, so let's view that data. So let's just glimpse. Let's glimpse hotels, and we should see. Oh, it didn't. Hold on. Sorry, I didn't do what I ever tell everybody to do. Okay, load up your tidyverse in your console. Click your little green button, and then load up your hotel's data frames so you have it by clicking those little green buttons. Go read in.
What?
I'm just.
The tidyverse? You just go to the libraries?
Just click this little green button. Just click it.
What?
And then you're done. And then click the next one down. You're running these little chunks on your console so that you can, you just want to look at the data. So you load up your hotels and you glimpse it. And if you look at, I just want to look at arrival date month hotels. Yep. No, right?
You go just a little forward.
Tell me when to start.
Okay.
Okay. Arrival date month is a character vector, and it's the names of all the months. So that's what that x-axis is that we're initially looking at. When it plots it on geom_line, though, it's ordering these guys in alphabetical orders. So it goes April, August, and then December, February, January. And a lot of the time you'll see it. Really?
I'm gonna show you where actually can make.
Are you looking on our Studio Cloud output? Mark down. Bottom of that, you'll see that so the task is to put those in month order, right? That's the task that we're trying to do. And if you see that your data is ordered alphabetically, most of the time it means that you've got a factor that's just been default ordered. And so now you got to figure out how you're going to order this guy. And the way you need to do it is you need to give the factor some implicit or some explicit order that's not alphabetical. And I'm just going to pop over to my solution because it took me a while to do this.
So wait, can you just hold on a second?
Okay.
So where it says arrival date month.
Yeah.
And looking at the glimpse.
Yeah.
So that says character.
Yeah.
But we don't really know if it's date, right?
It's not a date. Yeah. It's not a date. It's just a character, but it gets interpreted later in the ggplotting.
So we couldn't fix it by just changing the type.
No, I don't think so. I think you need to make it a factor and then explicitly make an order in the factor, and that's how you kind of do it. It's a little magical.
What about the class stuff that we were doing.
And it doesn't, yeah, an ordered factor. We ordered the factors. Yeah, and so the factors.
We had the DSMS.
Yep, those are factors. Yep. And that's what we're going to do. We're going to create an ordered factor. So if we look at, let's go back here now. If I go dates, okay, so if I so we're looking at factors. If we look at the four cats, you can see that there's a bunch of ordering. Basically, a lot of the stuff that four cats does is ordering.
Well, where are you?
I just Googled four cats, and so this is I'm just trying to get to, this isn't the right place. Ordering by another variable. So if I want to order.
Well, they give you this other thing that we could look at too, right?
Where?
Oh, this thing, forecast typers inspiration thing.
Okay, that's probably the
Yeah,
place to
that's
go
the
then.
link.
Okay, I went to the
That's
wrong
just-
place. Okay, maybe that is a good place to start, actually. This one. Okay, sorry.
I'm reading it.
Okay. I mean, it's still a little, it's a little bit not clear. Basically, there's all of these things you can do to reorder your data. And I did two of them, and I just kind of want to show you what I did because it's not, I don't think it's super intuitive, but I think if you do a couple of them, you can kind of get a pattern. So I want to show you the pattern. And there's two ways to do it. One of them is I'm going to start with this one. The relevel. Is it too tiny? That better?
Can you not show your team screen?
Teams? You can drag that out of the way. That's not me.
That's you.
So FCT relevel will take a variable, and you can make an explicit order with this relevel function. So let me pop over to relevel and just see if it makes any sense. These help pages I didn't find super helpful. But the way it says factor relevel, FCT relevel, you take in a factor or a character vector. So we're taking a vector of character. Yep. And then some way to reorder. And this part is so abstract, it's difficult to understand. But if you look at the examples, for example, if I relevel, I'm not quite sure why they're not putting all of them in, but if you do put all of them in, you can actually, you can explicitly set the levels in your factor. This one, for some reason, is only doing B and A. But if you do, BADC, it would re-level those at BADC, and then when you plotted them, it would come out in that right level, in that right order. So let me just pop over to the solution, which is, if you take this arrival date month and you use this FCT for cats relevel function, and then you put in the months in the proper order, then you can get your plot to come out properly. So that is one way to do this. And another way, which is basically equivalent, is to create a another variable that converts these character strings into numbers, and then uses the order of the numbers to order the factors. That's what this reorder one does. But I thought the relevel made more sense. It was easier to understand. I'm sorry, what? What did you say?
In order.
Where's in order? Yeah. So there's some implicit way that it will be ordered if you don't explicitly order it. So I felt like this is like really difficult to figure out on your own, so I kind of just wanted to give it to you. But maybe type it in and see if you can get it to work, then you'll have it in your solution, and you can refer back to it if you need to. I can actually copy and paste this into the chat, so you can actually just pull it out, because it's stupid to type it all in. I don't know, can you copy that out of the chat in any meaningful way? Maybe. The rest of it isn't changed.
Is there a way to, there's no way to just change the class to date?
It wouldn't help you because it's an order thing. It's not like it doesn't care about the class of the variable. It cares about the order.
Date has is a kind of thing you said.
Yeah, if you numbered it, that's kind of what this
Well, it's ordinal.
month number thing is.
Is it, are dates ordinal? You have to.
Months are ordinal, but you have to give it an explicit order. I was confused, actually. I thought there would be a helper function that would know this, that would know enough about like seeing these months and actually do the ordering for you. And there may be a way to do it because people do it so much, but I didn't find one, so I just did it by hand. And this may not be the most efficient way to do it, but it's a way to do it.
Where did you put it in, what line?
Right after hotels, right after the pipe after hotels. See if you guys can get that to work, and then if you want, we can also talk about the dollar. That's another one that just I had to Google around. It's not like, it's not something you think through. It's something you have to go find the answer to because it's very specific.
What's happening on line 12? Should I have not uncommented that?
I don't have anything on line 12. Can I see? Or do you want to share? Do you want to share your screen? It's reading the date.
It's commented out, so it's not doing anything.
Yeah, that's just a comment. It's telling you where it's from. It says from Tidy Tuesday : So, do you guys want to do that, or is this too crazy?
Do you want it on line 27?
I don't have. Why don't you share your display and we can do that? That way it's easier.
I haven't changed anything.
Line 51 for me, but oh, it's because I put a bunch of stuff in. Yeah, my lines are all messed up. Okay, you know what? You know what I'm gonna do is we're gonna do this. I'm gonna take this expression. I'm gonna put it over here in this one, and then yes, it is line 27. Sorry about that. So I'm gonna add that guy to here. That hopefully you can cut and paste right out of the chat, and I'm gonna reknit that. See if it fixes our problem. Yeah, it does. Okay. Do you want to share your screen?
Do I need to type at the end of it?
Yep. Are you guys able to do this one?
Yeah.
Okay, good. And then we can, if you want, we can play with this the dollars, how to add a $sign on the y-axis. That's another sort of just Google for it, but it's this scale. If you pull in the library scales, let's do it over here. I'm going to add another library called scales and knit, and I don't know if I have to install it or not. No, I guess not. And then again, this is just like, just got to go Google around and find it. If you, after geom_line, if you scale y continuous, where your labels equals this function label underscore dollar, it will add a little $sign to all your labels on the y-axis. So after geom_line, just put that statement in and reknit, and you'll get this goofy y-axis with the dollars on it. Here, let me put this into the chat too. So those are two abstract things that you just gotta, I guess, Google around and find out if you're faced with it.
Yeah, don't you think you could do the same thing on scale X continuous? Label equal month date?
I bet there's lots of ways to do it. I didn't look at that, but there might very well be. Yeah, there might be. I'll look, because it would be nice to not have to make all this extra stuff, but not right now. So just in the interest of time, let me just see how much more we have to go through. Okay, we do want to go through dates. So did everyone get to those answers, or is anyone stuck anywhere?
Yeah, I got an error.
Yeah, I got it.
You got it. All right, let's just zoom on, because we're going to run out of time. Okay, so we kind of struggled through that one. And now let's talk about dates. So there's a package called Date, which makes working with dates a lot easier. I guess it's not part of tidyverse, it's tidyverse friendly, but it's very useful. Lubridate. Okay, so we're gonna play around with dates a little bit. So one of the things
You could have also sorted the data itself, right?
no, not really, because I don't know. We'll have to talk about it later. We have to take it offline. I'm not 100% sure. I don't think so though. Maybe. We'll have to look at it. Let's just talk through the dates and then we'll come back to that if we have time, okay? So I'm just selecting out these arrival, anything that starts with arrival out of hotels, the hotels data frame, to get the year, the month, and the day. Okay, so now I've got those data, but they're all in separate columns, and I want to get a date out of it. So I can use a lubridate function to get the data out of it. So there's this function called glue, which sort of glues different variables together, and all this is doing, I believe all this is, oh, sorry.
Yeah.
I zoomed ahead and made a mistake. All glue is doing is gluing these variables together. We haven't oh, sorry. We haven't talked about actually turning it into a date yet. So glue just glues variables together. It's out of a library called glue. I don't know why this,
So the first thing is what?
I don't know.
Okay. Want to just like did you show everybody the table and the previous slide?
I did. Yeah, so in the previous slide we have we've got a year, a month, and a day, but they're all in different variables, and we want to turn that into a date somehow. Okay. So the first thing we do is we need them all in the same variable, so we glue them together using a library called glue, which just glues variables together. So I'm going to create a new, I'm going to mutate, create a new variable called arrival date, and then just glue these guys together. They're just characters. It's still just a character string. It's of type glue for some reason. And then relocate just takes it and puts it in the front so that it's not, there's 33 columns, and we're working with, we want to just put it in the front so that we can actually see it when we print it out. Okay, so now we've got these three things glued together. So you can count bookings on per date, but the date's still just a glue. But since they're all in the same variable, you can't actually treat them as a date because they're all unique. And so for each date, I can do counting, but I may not be able to get order right because I can't order by date. And this is just a visualization of this glued together date, but if you look at the x-axis on arrival date, it's a bunch of gobbledygook, and you don't know if this is actually in order of the date or not. So we want to turn it into, like you were just saying, we want to turn it into a date and then order it by date so that the geom line shows it. That might have been actually the simplest way to do it. So like we talked about before with the ordering of stuff, if your month starts with an A, chances are it's not ordered correctly, and it's just ordered in alphabetical order. And so we have to figure out how to order these this column properly. So one way to do it is to construct dates using this YMD function from lubridate, and YMD stands for year, month, date. Year, month, day. So you can actually, it'll take a year, a month, and a day in a string and turn it into a date, an actual date type, date class. So now I have dates. Now I can order stuff by dates where I couldn't before because there was no easy way to do it.
Where did you do that?
So before, over here, we just glued stuff together,
Right.
and what we made was we made a character string basically out of 3 variables,
Right.
and a character string of 2015 August 1. And so if I don't have any way to order it other than dictionary order. I can't
Yeah, I'm not
order it by
seeing
date.
where do you turn it into a date?
Yeah. So if we go down over here, YMD is doing it, this function called YMD. Are you looking at the slides?
Yes.
So I'm highlighting it. YMD, arrival date
date
equals YMD. Sorry, the highlighting looks like the same color as the
Okay.
previously
Previously say
highlighted.
glue.
Yeah, I used to just say glue, and now I'm wrapping it in a YMD function. Yep. And that turns it into this date vector, and then I can sort by date and stuff. Or we should go back and do that because that might have been the easiest thing to do. Except for January wasn't a date, so if you convert it to a date, that's what you were saying. Okay, so now we can look at okay, we've created this arrival date, and then we can count by arrival date, and then it's just in the order that you're getting it, but it's counting with dates instead of with character strings. But if we wanted to order it now, we can. And if we wanted to show the time series, so before you saw a bunch of gobbledygook on the x-axis, and now the ggplot knows how to interpret it because they are encoded as date class, that column in the x variable. Arrival date is the actual real date, and so now it knows how to decode it, and it will order it appropriately. So it's ordering it because it knows the order of dates, and so that, it's sort of like a factor, but it's not, it's a date.
That's group.
So geom_line needs this group thing, and basically group just says just treat everything as a single data stream, a single time series data stream. We've used group before to make two lines, like what was it, approve and disapprove in that political rating one. But here, if you just say group equals 1, geom_line needs something in group, and so any constant would just says put them all together in one line. It's just an artifact of how you have to use geom_line. That make sense?
Yes.
Okay. All right, so that's how you would do that. So that's cool. Now I can turn this arbitrary set of stuff into a date and then make a real time series analysis of it. And then I can do some other cool stuff. I can use. Well, the other plot was ordered completely differently. The data are the same. They're just there.
No, I mean the smooth plot.
Oh, yeah, I know. The smooth plot looks quite different. Isn't that interesting? If you look at the range on n, it goes from 100 to 200. So this is very, this is mean data. And if you look here, that it's going from like 25 to 400. But I found that interesting too, that you got to kind of stare at a little bit to see.
Yeah, I don't know. This looks like the rolling average of 5 days or something.
I'm not sure.
That's really.
Yeah, we'd have to do a separate analysis. If we overlaid the two, we could actually see if it made sense or not. It kind of does. There's a peak in 2016 July and 2017 July.
Is it?
Oh yeah, maybe it's offset or something. I don't know. I mean, we'd have to overlay it to see if it made sense. It is a little wacky though, isn't it? Anyway, let's keep going because we are gonna run out. Oh no, wait, hold on. I guess we aren't. I'm gonna run out of time because that's the end. Maybe we should overlay those. I bet there is an error in here. It is a little odd.
Well, that was a lot. Maybe we could just digest it and get it on.
Yeah, there was a lot in there. So we went through data types, data classes, and we did this application exercise. So yeah, I think we probably want to end there. If you guys want to take a shot at the lab, it's actually pretty interesting. It's starting to look at spatial data. We're not looking at maps, but
which one?
the lab.
It says application exercise. That's what we did.
Yeah, we did the application exercise. So
where are we up to?
We did data types and data classes, and this first application exercise that were 2 parts to it. So on Wednesday, we're going to do importing and recoding in another application exercise. And what I had said earlier, and let me just bring that back up, is because we have 2 application exercises, you might want to try and do the lab on your own, and then we can maybe talk about it on Wednesday if there's time. It's interesting because there's some spatial data in there, even though there aren't maps, but there's some spatial data about it's about the correlation between the
So we know
location
which
of
one.
Denny's and the location of La Quinta motels. Next time there's 2 slide decks and an application exercise, yeah. So we may or may not get to the lab. That's why I'm just suggesting to try it out on your own. If you get through some of it, then maybe we can talk about maybe the latter parts that might be more interesting. So, but I think that's probably good for tonight. Yeah, that was a lot of content. Any questions? Yeah, okay. Maybe there are some readings that might help clarify some of this stuff. There's a good reading on factors here. But Wednesday importing and recoding, that's pretty straightforward. Okay, so I guess we can end a little bit early tonight.